Okay, here's a mini lesson on heating curves. With heating curves, a lot of the information you just have to remember. The inclines represent heat added going into temperature rise, also known as kinetic energy. So this is a kinetic energy change. Every time we get a little rise, the temperature is going up. We can see the temperature is our y-axis here, and it's going up. So every time we're going up an incline, we are increasing temperature or the kinetic energy. Um, and if we're going up the heating curve, it is endothermic. And if we're going down the heating curve, it is exothermic. So if I'm going from a gas to a liquid or condensing, it is exothermic. Whereas if I'm going from a liquid to a gas, boiling, it is endothermic. I'm adding energy into that to get a change, a phase change. The flats represent the phase changes. So this is where all the action is happening. This is where ice is actually melting, turning into a liquid. This is where a liquid is actually boiling and turning into a gas. Um, and this is a change in potential energy. You're actually changing the energy of the phase, which is a potential energy change. You notice you're not changing the kinetic energy anymore. Whenever you're instituting a phase change, it's always a potential energy thing. The energy is going to break the kind of hydrogen bonds between these things. And that's a potential energy change. So basically, potential energy on the flats, because it's not changing the kinetic energy. The kinetic energy is a temperature rise, right? That's the definition of temperature rise, is a change in kinetic energy. And there is no temperature rise. Okay, we got this. All right, let's just take a look. Now, I've done it on two sheets, but you're going to see it on one sheet, obviously. Okay, let's just get this nice. There we go. Okay, which letters represent a change in potential energy? Okay, so potential energy is D and B because it's the flats here, right? And kinetic energy, it's the rises and potential energy. Which letters represent a change in kinetic energy? So that's E, C, and A. And which letter represents a solid? That's going to be down here. A liquid, that's C. And a gas, that's A. Remember that on the flats, we have a little liquid and a little gas. So this is kind of a mixture until we get to right there. And then, oh, yeah, that's the problem. Okay. On the flats, this is a mixture of liquid water and gas right here. It's slowly going over to gas until we get to this point right here, and then it is all gas, right? Okay. See what else we got on here. Oh, by the way, yeah, I guess you couldn't see my letters either. Okay, so what letters represent a change in potential energy? That's going to be B and D. That's where potential energy is changing. Everywhere else, kinetic energy is changing. Kinetic energy, A, C, and E, the slopes. Changes in temperature are by definition a change in kinetic energy. And a temperature change occurs during a phase change, true or false? That is false. We can see that during the phase changes, the temperature does not change. It is steady at 100 degrees right here all the way across until everything is gas. Which letter represents vaporization? So that's B. Condensation, well, that's just the opposite going direction of B. Melting, that would be D, going from a solid to a liquid. Melting, going from a liquid to a gas, that's vaporization. Going from a gas to a liquid, that's condensation. Is a solid changing to a liquid an endo or exo? Okay, so a solid to a liquid, and we've said that going up is endo and going down is exo. So this is definitely going up. So we're going to say that that's endothermic. We have to add energy to get this ice to melt into water. That's it, guys. Short one.